Hello everyone, this is Singh and today we are discussing how we can migrate critical traffic at scale and without any downtime in our system. So how can you actually do it? This is actually based on a Netflix tech blog which is published on their tech blog site. I will also share the link with you in the video description. But before that, as you move forward, consider subscribing the channel MsDeep Singh. I know it's been a while since I published my last video, but let's see how it goes, and from now on I will try to publish the videos regularly. So today we are discussing how we can migrate critical traffic at scale. If we look at the set of requirements, these are the set of requirements specifically to build any kind of system. Let's say we want to migrate traffic from system A to system B. Let's say there was some system enhancement that we did. This entire system was not scalable, so we re-architected it to system B, and now we want to shift this customer traffic from one website, one system A to system B. So how can you actually do it? And it should be done without any downtime in the system, because customer ideally should not know if there is any architectural change or what is happening in the backend. They don't care about it. We only care that the customer experience should not be impacted. So these are the basically a requirement: migration of traffic from existing system to new system. These are the base requirement. Then what you also want to do is you want to run both systems in parallel for confidence building. Now for time being, you also want to run the traffic on A and as well as B, so that you build a confidence that B is working as per our expectations. So what you can do is, there are a couple of solutions that we will be discussing in this video, that if you run both of these systems in parallel, ideally you should be able to run some kind of analysis on what kind of response you are getting and all those things by building metrics and all those analysis, by doing the processing on the response structuring. So that will help you to build the confidence over your new system that is being architected. Further, we don't want any downtime issues, so there is no customer impact. This is our, like, again, a very important requirement that we want to serve it. This specific video only focuses on the solutions and systems with stateless and idempotent APIs. So assume that a system, we are using particular API, so it do not matter how many times you are hitting the API, you will get the same response. Basically, even if you hit the API at second time, let's say you want to fetch particular video, right? So even if you fetch it multiple times, you will get the same response. This is what we mean by the stateless. Basically, the system is not maintaining any state in the database for the first API it got. Let's say it got the first call in state saved is state A, right? Now again, if you got this request, then you save state as B. So this is not the scenario. In this case, we will be discussing simple solutions if you want to do the migration in case of stateless and idempotent APIs constructed systems. So let's move forward on the solution considerations. So first, before that, let's discuss one concept around replay traffic. This is around the second requirement which we had, which was run both systems in parallel for confidence building. So what we mean by replay traffic is, for production traffic is duplicated and passed to two different paths. So what we mean by two paths is, again, we discussed that we have two systems, right? We discussed that we have system A and we have system B. Now to pass the traffic to both these systems, what we can do, we can pass the production traffic to both these systems and then see how each one of the systems are performing. Now what are the benefits of this? First of all, sorry, first of all, you are not doing the testing on some test scenarios or test APIs or test traffic. That is not the traffic which is generated by system. It is actual production traffic you are doing the testing on. So actually you are doing the testing in the actual environment, the actual traffic you are getting, and then you will see how your system is performing. So what are the benefits you will get? The first benefit is you are able to test the system on original traffic. You are not doing this on the system generated traffic, but the system is being tested on the original traffic, on the original customer production traffic. Second is load testing and tune accordingly. Now since, let's say this is your new system B, you are getting the traffic. So first, let's say you started with 10% traffic. This is your system A, this is getting 100% traffic. So it will continue getting the 100% traffic, but 10% of these requests are redirected to system B. So we'll see how the system is performing with the 10% of traffic. Accordingly, you will then increase the number, let's say from 10 to 50%, then 100%, something on those lines, and then you will see how your system is performing. Is it scaled well? Is it scaled well? Are you seeing any some issues with the system? So these kind of things can be load tested, and then if there is any requirement, then we can tune accordingly. If there are required, like we need to change some kind of configurations, right? Let's say you have to, there is some CPU contention, so you can increase instance size, or there is some memory issues. So all these kind of things, memory leak, disk issues, anything hard related to hardware or software configurations, or any bugs in the software, these kind of things you can figure out via doing the testing via production traffic. C is functional system correctness. This is around the software. So in this load testing, we figured around the hardware testing mostly. In this specifically functional testing correctness, what we mean is that system is behaving as per the required behavior, right? We said that we don't want to impact the customer experience. So if we don't want to do that, we want that system is behaving properly as per the requirement. It is not hampering the customer experience. Actually, we are not serving the customer request with this system. We are just passing the traffic to see what kind of response we are getting. D is system performance, hardware latency. Like we can also discuss around the load testing, we can also see the complete system performance. They are kind of related, where you are checking all the hardware related issues. If the API is taking more than required time, let's say our latency is 100 millisecond, it's kind of more, let's take it's 10 millisecond. Okay, so if the API latency is, let's say, greater than 300 millisecond, now there is some issue. So can we figure out that? Can we fix that issue? So these kind of issues you can figure out beforehand and then work accordingly to fix them. Got it? Another one is operations. So when you deploy your application B, right, you will set up some kind of metrics. You will set up some kind of logs as well. You will set up some kind of alerts. So you can check all these things. If there were some issues, you were able to, the metrics are successfully generated. Basically, you are getting proper alerts. You can debug via the logs. So you can check all these functionalities in the operations management of the system. Got it? So these are the basic benefits if you do the testing via production traffic, and obviously without impacting the customers. Now let's move forward with the how we mean by what basically we mean by running the traffic on both the systems parallelly. So this is your production traffic. There are let's say this is your Netflix customers. So you have multiple devices here. This is your mobile devices, this is your laptop device, this is computer device, any of the devices which you have. Basically what you are doing is the traffic is directed to two systems. One is existing system, one is new system, and then finally you capture the responses from both of these systems. Then you will do the analysis, some kind of batch processing, which we will be discussing at the end of this video, and then finally generate reports which can be useful to see if the behavior is as per the requirement. Now let's move forward with the approach we can take to do this behavior of replicating the traffic from one system, basically replicating the traffic across two systems. One is existing system and another one is new system which is being re-architected. So first one is device driven. When I say device driven, you are actually replicating the point of contact, or the point from where the traffic is replicated is your device, the customer device which you are talking about. It can be mobile, it can be computer. So from device itself, the traffic is sent from at two endpoints, you can say. So one is this prod endpoint which is actually in place, and this is your duplicate endpoint where you are sending the traffic. So which is the prod endpoint is hitting the traffic at existing service, and the duplicate traffic is hitting at new service. Now this when you are sending the traffic from device to the new replay traffic, or the new traffic to the new service, it basically discards the response, right? We don't want to consider the response of this. We just want to gather the response and then finally use it for comparison. We actually are not using this response to serve the customer request. This is just for testing, for our confidence building, right? So what are the benefits? Basically benefit is one, right, that we are able to test the traffic, but there are some downsides to this approach. What are the downsides? So there is extra burden on device, right? You are handing over the responsibility of sending the traffic to two places from the device itself, which is causing the burden on device. What kind of burden? One is resource consumption, right? Why resource consumption? This device is actually responsible for sending traffic to two places, so you are actually consuming resources more than required. So you are adding extra burden by adding more resource consumption. What is the second point? Second point is device application dependency for release management. Now let's say, in this case, let's say that when this traffic would replay to a new service, you figured out some issue, there is some issue, and then we have to change some kind of configurations. Now if you want to change some kind of configurations, let's say there was some change in the API structure, so if you, or anything, right? So if you want to change something, you will need a new version on the device, you will need a new software version on this device. That means that you are dependent on the release cycle management of this device software. We are doing the change in the backend system, but we have to do release management in the front end system as well, the software which is running on device. And definitely it can happen that they are not in sync with each other, right? The backend services can go more frequently, but the device software, let's say, goes 4 weeks per 4 weeks, right? And this goes every week. So there is actually dependency which you are creating that definitely we can skip, right, if we don't go by this approach. So this is a kind of extra burden which we are generating. Okay, moving to another point. So this untested server calls from device is not a good idea. Why? Because this actual path, right, this is in testing phase right now. This is not completely tested flow, but we are hitting the servers, we are hitting this path via a device, which might not be a good idea. There can be possibility that it is not completely secure and the hackers can steal some kind of information or do some kind of work which we ideally do not want to do. So this is definitely a not good idea to do that. So there are definitely, we got to know that there are certain disadvantages of going through this approach. So what is our second approach? Second approach is server driven. So here we were doing, or like we are handling everything, the traffic duplication and all, like basically replaying the traffic to production server as well as this to new service or which is being architected from device itself. If you can do it from the server, right? So what you will do, this is your actual device, then this is your API gateway, this is your API. So for particular API, the particular API will hit to prod as well as to new service, right? So the full responsibility here is on backend. The device is untouched by these changes. So one benefit you will get is iterate over changes faster. There was one issue with the previous approach, that untest which device application dependency for release management. That issue is resolved now. We are not dependent on the release management cycle of the device itself, but we can reiterate the changes of the backend services faster because we don't have the dependency over our release management of device, right? But there are disadvantages as well, definitely, right? There are pros and there are cons. What is the con? Additional coupling. How? Replay logic alongside the production code. So from this single API you are hitting the production as well as to new service. So you are actually running the logic alongside your production code, which is actually solving the customer traffic, which might not be a good idea. And additionally, there can be bugs in replay logic that might impact the actual traffic. What if when you are, let's say in a single API, you are doing some kind of if else, right? Or you are just making this parallel calls, right? So there is no if else, definitely. So you are making calls to API 1 and API name can be kind of same, but it is hitting on endpoint 2 and it is hitting on endpoint 1, both of existing service and new service. So actually it can introduce some extra codes and which can impact the actual traffic which serves the customer. And definitely our one requirement was, we don't want to impact the customer experience, right? We don't want to impact the customer experience. This is our important parameter. We have to live with it. Now the final architecture, which is like best architecture in this case is decoupled dedicated service. So here what we were doing is we were handing over that responsibility of replaying the traffic to this API itself, right? What if we can decouple that entirely? So this API will be the replay logic will be handed over to separate replay service, which will send traffic to the new service. So it is entirely decoupled from here. It is entirely decoupled from here. So first benefit is definitely complete isolation from replay logic. So you are solving both the disadvantages of approach one, where you are decoupling the logic from device, and also you are decoupling the logic from the existing production traffic. So there is no dependency on device or backend service. Replay service record responses from prod and new service traffic for offline analysis. So what this replay service can do is it can record responses from both that prod traffic as well as existing service, and then send it for further processing, which we are discussing right now, to compare and do an offline analysis to generate finally a report, which we can see if there are any some anomalies what we want to fix, right? And other things as well, such as were there any issues in the servers, or were there any issues latency, like completely management of metrics, so that you can figure out and then fix that. Okay, let's move on to the final part. Once you gathered the responses in replay service, what you do about it. So this is a replay service, port and replay traffic. All the responses which are captured are sent to Apache Iceberg. This is similar to S3 Glacier, which is a low cost storage kind of solution, where you store your data and further it is done, like it is analyzed by doing batch processing, and finally a report is generated. So you can think of like this runs once per day in the morning 7 a.m. Let's say you have scheduled this job via CloudWatch events, and this is your EMR cluster which runs to do this processing, and then finally generate the report, which is stored somewhere in S3 or something, right? Or you publish metrics on CloudWatch. Anything, whatever you are doing, basically you are generating a report that can be used to view our progress of how our new service is performing. Is it able to serve our customer traffic or not? Okay, now let's further figure out and move towards what are the things you are doing while you are doing the batch processing. First one is normalization. So what you do in normalization, the responses of both services can be different, such as extra attributes on change of data structure. Now let's take this example. So let's say in your existing service we have API 1, and in new service we have API 2. In this case, let's say the response you are getting is timestamp, okay, and there is some called list string, right? And this as well you get timestamp and you get map string. Okay, so there is a change of structure here. The response timestamp can definitely vary, because the response generated from both the existing service and new service can vary. You have sent the request at the same time, but the response generation can vary by microsecond or by nanosecond, but it can vary definitely, right? Plus, so you can totally ignore this timestamp. It is anyway not adding any value, right? We have separate metrics for latency and all to see how much time the API took to serve the request. Another thing is, if there is any data structure change, let's say, right? So this list string was modified to map string. So you will have to normalize the data such that it is easy to compare. Now in comparison, we have to create metrics for matching and mismatching responses. Okay, we have to see what are the successes and what are the failures. Or also we are recording the mismatched responses for offline analysis. As in offline analysis, one should see the metrics if there are any much more differences you are saying, and there are a lot of mismatched responses. If you are storing them, then you can definitely check whether you are storing in some kind of database, or you are storing in, let's say, dumping somewhere in the log files or logs. Anywhere you are doing, basically you are dumping them so that you can view it further if there is in further analysis required around it. Another point is lineage. Now what we mean by lineage is comprehensive summary of data versions or checksums for dependencies involved. Now let's consider this example only. When this both existing service and new service are doing some kind of operation, it could be possible that is interacting some set of services, right? Let's say service A, then service B. Okay. Similarly, it is interacting with some kind of service A and service B. and it might also be interacting with service C. Okay, now two things. One first thing is there can be different number of services which they interact. So there can be different number of dependent services which these services interact with, right? So that is one thing. Another thing is it could be possible that it is using the different version of this service and it is using the different version of service. So to avoid such scenarios, as in we don't want that due to lineage the data which is generated, there are a lot of mismatching responses. We don't want that, because that will create anomaly and we will not be able to gather concrete data for comparison, that if the service is not performing or not generating responses as per our requirement. So you can do that. So responses can all vary based on different services involved, so you will need to resolve this. Okay, so after doing all these things, you do the in batch processing, you do all these steps and finally generate a report which is a clean report that can be used to do our analysis and take proper decisions if that there is some issue with the bug, there is some bug in the system, or we are not getting the response in proper time, or anything which we discussed beforehand. Now a few additional things. We can also consider comparing the traffic instead of offline analysis we can let me repeat. We can also consider comparing live traffic instead of offline analysis of responses are not too complex. So instead of doing this offline analysis here, as we get this traffic, right, you can do the comparison at runtime as well if it do not require any complex processing. So you can do that as well. And in case of stateful, all these things which we discussed here, the three approaches which we discussed here are applicable to stateless systems, as the API behavior do not change on the subsequent calls, or the API response do not change or the subsequent calls. But in case of stateful system where the API calls, if they are repeated, there are some kind of states management. So in that case, you will need a separate data stores that are in sync, or let's say you have these two systems. This is your existing prod system and this is your new service, right? So they have to be in the same state as you start replaying the traffic to new service, along with the responses capture state as well for comparison. Definitely along with this is in the first all the examples which you took, we were only storing the responses of two systems for comparison, but we will also need state in this case, for particular state this is the response that was associated, so that will be useful for comparison. So these are the all things which we'll be discussing today. If you like the video, please consider subscribing to the channel MsDeep Singh, and we will be making more such videos in future. Till then, stay safe. Tata, bye bye.